Hello all, I am Disha, an electronics and communication student at Sri Venkateswara College of Engineering. I am here to give a presentation on finite state machine, which is related to a subject called embedded system. Finite state machine model. As name itself represents, there must be a finite number of states. To understand this topic very well, let me consider a real-time application as an example. I am considering seatbelt warning as an example and it is automotive based. Okay, the system requirements are captured. As we know, the seatbelt warning comes only when ignition is on and seatbelt is not plugged up or fastened. And the alarm or a beep sounds till 5 seconds. Only the alarm gets off when the ignition is off, or else the seat belt should be plugged in, or else the alarm sound should exceed more than 5 seconds. These are the states or conditions. For a finite state machine model to be built, there must be a states and events. For my example, seatbelt warning, I have considered three states. Those are alarm off, waiting, alarm on. And the events are ignition key on, ignition key off, timer expire, alarm timer expire, seatbelt on. This is the finite state machine model for my example seatbelt warning. As I mentioned, there are three states. They are alarm off, alarm on, and waiting. And there are three events taking place: ignition key on, ignition key off, seatbelt on, timer expire, alarm time expire. Working of the finite state machine model. For an example, seatbelt warning. The ignition key on event triggers the 10 seconds timer and transition the state to waiting. When the events seatbelt on and ignition key off occurs during the waiting state, the state is transited to alarm off. When the wait timer expires in the waiting state, the event timer expire is generated and it transitions the state to alarm on from the waiting state. The alarm on state continues until the seatbelt is on or ignition key is off. Event or alarm time should be expired. Whichever occurs first. Also, this alarm on state discontinues. The occurrence of any of these events transient the state to alarm off. The wait state is implemented using a timer. The timer also has certain set of states and events for state transition. Using the FSM model, the timer can be modeled as shown in the figure which I have shown in the before slide. Let us consider another example to illustrate the finite state machine model, and the example is design an automatic tea or coffee vending machine based on FSM model for the following requirement. The tea or coffee vending is initiated by user inserting a 5 rupee coin. After inserting the coin, the user can either select coffee or tea or press cancel to cancel the order and take back the coin. And I have told in the before slides that FSM model should have states and events. For this example, I have considered 4 states, and the states are wait for coin, wait for user input, dispense tea, dispense coffee. This model is the FSM of tea or coffee vending machine. I have considered four states. State A, wait for coin. State B, wait for user input. State C, dispense tea. State D, dispense coffee. In the state A, when the user insert a coin, the transient state is B, where it have to wait for the user's input. When the user input is tea or a coffee, that is, he or she has to press the tea button or a coffee button. When tea button is pressed, the state transition is to state C, that is, dispense tea. When the user presses the coffee button, then the state transient is to state D, that is, dispense coffee. And there is another event occurring in between the state A and B, that is when the coin is not proper. If let us say 5 rupees coin is required to dispense either tea or a coffee, when the user inserts 2 rupees or 1 rupee coin, the event does not occur, and there is no state transition from A and B. It just gives the cancel order and the coin is out. That is a possible state. And another state is when the state A to state B, when the transient occurs. In the state B, there are three buttons, that is tea button, coffee button, and then cancel the order. When the user presses cancel the order, then from the state B, the transient occurs to the state A. And after pressing the T button, the state C is transiented, and the dispense coffee is the action. Dispense tea is the action taking place. When the event coffee button is pressed, there is a state transition from state B to state D, and the action taking place is dispense of the coffee. And once the dispense of tea or a coffee is done, again the state transition from C or D occurs to the state A, that is wait for another coin or another input. As I told in the last slide, the event insert coin, 5 rupee coin insertion, transition the state to wait for user input, and the system stays in this state until a user input is received from the buttons cancel, tea or coffee. If the event triggered in wait state is cancel button press, the coin is pushed out and the state transition to wait for coin. If the event received in the wait state is either tea button press or coffee button press, the state changes to dispense tea and dispense coffee respectively. Once the coffee or tea vending is over, the respective states transition back to the A state, that is wait for coin. Thank you for watching the video, guys. Please do like my video. If at all you didn't subscribe to my channel, please do subscribe it and stay tuned for more interesting videos based on electronics and communication topics.